All right, so this is going to be a sneaky use of u. All right, so the problem is we have two terms in the denominator. The solution, we're going to substitute to make it one term. So the u is going to represent the denominator, 3x minus 7. And if it wasn't all linear, we might have a problem. But this will not be a problem. That means that du dx equals 3. We can multiply both sides by dx, so du equals 3 dx. We don't have a 3 represented, so let's pull that 3 out. And we'll divide both sides by 3. So 1/3 du equals dx. We've got the denominator taken care of. We've got the dx part taken care of. We don't have the 2x taken care of. Right? There's no 2x as part of the derivative. So we're going to represent that 2x in terms of u. We're going to simplify it, and we'll have something we can take the derivative of, because it's just going to be, we're not going to have two terms in the denominator, just a single term, just a u. So if u is 3x minus 7, right, then u plus 7 equals 3x. And u plus 7 divided by 3 equals x. So now we're going to substitute into the equation. We're going to, and we want 2x, excuse me. So that's x. So 2 times u plus 7 divided by 3 equals 2x. All right, so we've got a 1/3 and we've got a 2. Let's pull that outside the integral. All right, so we have 2/3. The 2x is now a u plus 7 divided by 3. The 3x minus 7 is now a u du. Let's write that a little nicer, right? So 2/3 times the integral of u plus 7 divided by 3u du. And now we'll just divide both terms by 3u. So we have 2/3 times the integral of u divided by 3u is going to be 1/3 plus 7 divided by 3u would be 7 over 3u du. All right, now on the next page I did the integrating because I needed more space anyhow. All right, so every one of them gets a, here I didn't separate it out. I multiplied by the 2/9 at the end. Either way. All right, so we have 2/9, and then I have it all in parentheses. So either I distribute the 2/9 to each of those terms, or we integrate and then we distribute the 2/9. So we have 2/9, because that back here, actually, let me just factor it out, and then you won't have to look at it that way. So I can factor out that 1/3 as well, so that we have 2/9 times the integral of du plus 7 over 3u du. Right? That, if I factor it out, there's still something there, right? So it's not a nothing, it's a du, or it's a 1. All right, so we have 2/9 all times the integral of du plus 7 over u du. We know that whose derivative is du? That's u. So now we have 2/9 times u plus, we can factor out the 7, but 1 over u is natural log of u. So we have 7 times the natural log of u, and then plus c. And now we need to substitute back. So f of x equals 2/9 times 3x minus 7, because u is 3x minus 7, plus and then 2/9 times 7, 14/9 natural log in absolute value bars, 3x minus 7 plus c. So a sneaky little use of substitution. You will find it on your homework. And once you get the hang of it, it wasn't that tricky. All right, so here we only have one term in the denominator. We definitely want to use a substitution, right? Because, well, dividing by e tan of squared x is probably not going to be that much nicer anyhow. All right, so what should u be? Well, don't make u have anything to do with e. All right, make u the exponent. All right, so we have u equals tangent squared x du dx equals, this is a chain rule, right? Because this is tangent x. There, I'll just put the derivative of tangent x all squared. Right? So that would be du equals 2 blop, right? So 2 tangent x times the derivative of the blop, which is secant squared x. The only thing we're missing is we don't have a 2. All right, so that means 1/2, oh, don't forget our dx, 1/2 du equals 2 tangent x secant squared x dx. There we go. All right, so we are keeping the e, and now we just have e to the u. So we have the integral of 1 over e to the u, and don't forget our 1/2. 1/2 times the integral of 1 over e to the u du. All right, so now we can integrate that. So we're going to have 1/2, and then we've got 1 over something. That's going to be natural log of e to the u plus c, or 1/2 natural log, got to substitute back, e to the tangent squared x plus c. And we'll put the absolute value bars around that. All right. So there's that one. All right. So we know, by the way, it can't be, when we have anything to the -1 power or 1 over, it's got to be natural log, because if we added 1 to -1, it'd be 0. That wouldn't make any sense. And I'm just going to leave it like that. All right, this one, the trig identity, if you recognize the trig identity, makes that a lot easier. All right, so who is 1 over cosine squared x? That would be secant squared x dx. And well, this is a really easy one. We don't need substitution at all. This one is tangent, so f of x, oh, I think I've been forgetting to write this as an equation. F of x equals tangent x plus c. Let's make sure I did the other ones. I did not on this one. F of x equals, yep, the rest of them are okay. All right, let's do the next one. All right, so we've got cotangent squared. All right, if that's one of the Pythagorean identities, if you don't remember it, that's okay. Cotangent is cosine over sine, so divide everybody by sine. So you got 1 plus cotangent squared x equals cosecant squared x. So now we could replace the cotangent squared x. That's a square. Looks like cotangent 2x. And in this case, it's a 3x. But we can replace the cotangent squared 3x with cosecant squared 3x minus 1. And then we can integrate that. So we have the integral of cotangent squared 3x, and we are going to still have to do a u du substitution. And then dx minus, oh, whoops, sorry. Let's replace the replacement. Cosecant, the integral of cosecant squared 3x. We're still going to need to do a u to u substitution, but we need cosecant because cosecant is easy. Dx minus dx. The substitution will be u is 3x, which makes du dx equal to 3 multiplied by dx. So du is 3 dx. Oh, we don't have a 3, but no problem. 1/3 du equals dx. All right, so now we'll replace this part here with the u, and this part here with a 1/3 du, and then all will be good. So we'll have the integral of cosecant squared u, or excuse me, 1/3 times the integral, let's factor out that 1/3, of cosecant squared u du minus, oh, and it really, that can be a dx because we're treating them separately, and then we'll substitute back before we write the equation. So 1/3, whose derivative is secant squared u? Right, well, the derivative of tangent is secant squared x. The derivative of cotangent is negative secant squared x. We're missing the negative, so this is going to be negative 1/3 cotangent u minus, and the derivative of dx is going to be x. Let's replace the u and we can write the equation, oh, and then plus c. And then we can rewrite the equation. So f of x equals negative cotangent, and u was 3x divided by 3 minus x plus c. There we go. All right, so this one was a little substitution, but what we had to do first was rewrite this into something we could actually integrate. So cotangent, not so good. Right? Tangent, not so tangent square, tangent and cotangent, not so good. Right? But secant squared and cosecant squared, very good because they're just the derivatives of tangent and cotangent respectively. All right, so anytime you have sine or cosine to an odd power, pluck off one, rewrite the rest with the Pythagorean identity, and use a substitution to integrate. All right, so sine squared x plus cosine squared x equals 1. That makes cosine squared x equal 1 minus sine squared x. We want to rewrite this as cosine x times cosine to the 4th power x. All right, that's okay. All right, so that just means it's going to be cosine to the 4th power, cosine x to the 4th power is going to be 1 minus sine to the 4th power x. Right? You can, all the even exponents are the same thing. All right, so now we're going to rewrite the cosine to the cosine x to the 4th power as 1 minus sine 4x, or sine x to the 4th power dx. Let's distribute, so that we have cosine x, and let's make them two separate, just like we did in a previous lesson, but this one's a little bit different. All right, so we have cosine x dx, that'll be 1, minus cosine x sine x to the 4th power dx. Now we can do a little substitution. I think I might have done it on the next page. Let's find out, because I don't have much room here. But u is going to be the sine x. That makes du equal to cosine x dx. All right, so we've got everything we need, and taking the derivative, or the integral of the cosine x is no big deal. Let's see, did I leave myself space? No, I did not. I did not do it that way. So I will squeeze it in here somehow. If I put that over there, I need to write smaller. All right, now we'll take the integral of the cosine x dx, because that's no big deal. Right? That was sine, whose derivative is cosine. It's sine. So this is, and I won't put the f of x until I get rid of any u's. So we have sine x minus, and then we're going to rewrite that. The sine is going to be u to the 4th power now, and du. Everything else is represented, right? So this part here, that's the du, the sine is the u, and the only thing left is the exponent. All right, so now we have sine x minus, and then u to the 5th divided by 5 plus c. Let's substitute that u back for the sine x. So we have sine x minus sine x to the 5th power divided by 5 plus c, and we can now make that f of x equals, as we got rid of the u's. You don't want f of x when you've got u's in there. Let me write that a little bit nicer, and we'll move on to the next one. Good enough. All right, so this is an easy one. The thing that's to the power is the x to the 4th. The derivative, so du is going to be 4x cubed dx. There's no 4, so 1/4 du equals x cubed dx. So this part here is going to be the u, and this part here will be 1/4 du, and everyone's represented. So we have the integral, we can pull the 1/4 in front, 1/4 times the integral of cosine, sorry, the cosine is left there, cosine u du. Right, because the x to the 4th has been rewritten, the x cubed dx has been rewritten. We're leaving the cosine because that wasn't a problem. Right, so we want the integral of 1/4 cosine u du, and that's just going to be 1/4 sine u plus c. Right, the function whose derivative is cosine is sine. We need to replace, so now that's going to be f of x equals sine x to the 4th, we're replacing the u, divided by 4 plus c, and that's that. All right, so let's go on to the next one. See, these aren't too bad, it just takes practice. All right, so now, who should be u? Well, we know that one of these functions has its derivative there, so u better be tangent x, not the exponent, otherwise we're going to have a problem. Just the tangent x, because the derivative of tangent x is secant squared x. All right, so we've got the tangent x represented with the u dx. We've got the secant squared dx represented with du. That's going to give us u to the 4th power du. right? So everything was represented except for the exponent, right? So this was the u, and this was the du, and the exponent remains. And now this is pretty easy. So this is u to the 5th divided by 5 plus c. And now let's just replace the u. So it's going to be f of x equals tangent x to the 5th power, all divided by 5 plus c. Right? And you can see that the 5 would have moved in front, and the two 5's would cancel. So we'd have tangent x to the 4th power, and the derivative of the inside, the derivative of tangent x, is the secant squared x part. All right, so we don't see any derivatives for tangent x, but if u is natural log of x, then du can be 1 over x, right, dx. So we've got everybody rewritten except for the tangent part, right? So the tangent is a problem, right? But let's rewrite this part here. So we've got tangent u du. Everybody else is written. Now, what if you don't remember how to do tangent, right? Then you could rewrite tangent as, so tangent u would be sine u, cosine u, and you could do one more substitution. Or if you remembered that tangent u was, that was kind of that unique one, right? So tangent u, when we took the derivative, when we integrated, right, we had the natural log of secant u. Right? Let's just make sure, let's just prove that, all right? Because you may not remember that, right? Especially because when you're trying to write these, you're like, oh shoot, what was that? I remember there was something with secant maybe, and natural log, or cosecant. All right, so if, here we're going to do another substitution, right? So let's make w equal to cosine u, and that makes dw equal, if we take the derivative of cosine, that's going to be negative sine. And of course, here, put the d over there. So dw here would equal negative sine over, just negative sine. Trying to think of too many things at once. U and du. All right, so then, just as a little reminder, so the tangent u part, right, because we're using sine over cosine, right? So if we let the w equal cosine, right, and then dw would be negative sine. So then we would be taking the integral, right, of w's in the denominator, right, and we're replacing. So the only thing we're going to have w in the denominator, and then everything else is dw, but we don't have the signs, the negative. So let's put the negative out there. Right? And then we would take the, if we integrated, this would be negative natural log of w. And what was w? W was cosine, right? So this would be negative natural log of cosine u, and then put the negative back, right? That would make that natural log of 1 over cosine u. And who is the reciprocal of cosine u? That's secant. So tangent u, when we're trying to integrate that, that would be the same as the natural log of secant u. All right, so I just wanted to remind you of how we got that. All right, so now that we know what the integral is, right? Excuse me, the integral of tangent u du. Now we can integrate this. This would be the natural log of secant u plus c. Replace the u with the natural log of x. So now we have f of x equals natural log of secant and natural log of x. And let's put that in absolute value bar. I guess if we put the first one, but let's put everything in absolute value bars. And my absolute value bar is plus c. So this was kind of a unique one, and you had to remember an integral that we did earlier. Ta-da. So natural log of the absolute value of secant, absolute value of natural log of x plus c. All right, a little bit of a weird one. Nice one. All right, so we're going to rewrite this as sine x times sine x to the 4th power. And this is very much like one we just did with cosine. All right, so remember that sine 4x is equal to 1 minus cosine x to the 4th power. All right, so now we can do a replacement. Sine x times 1 minus cosine, yes. 1 minus cosine x to the 4th power, just had to think for a second there, dx. And then distribute the sine x, so we have sine x dx, let's give it its own, minus the integral of sine x cosine 4x dx. And now we can do a substitution. So u is the cosine x, its derivative is negative sine x. I don't see a negative, so negative du equals sine x. No problem with the sine x part, so this is just going to be negative cosine x, and then, oh, we do have the minus out there. So that's all right, we'll just make it a plus. All right, so we now have a plus the integral of u to the 4th du. All right, so this part here, this, and this is all the du, right? Oops, if we remember the dx at the end. That's why I usually put the dx underneath it. I don't take that shortcut usually. And then the cosine here is the u. Right? And so we have now u to the 4th du, and we can integrate that, no problem. Negative cosine x plus u to the 5th divided by 5 plus c. I think this is, wasn't this, the other one had signs in it, right? Otherwise I've done the very same problem. But f of x equals negative cosine x plus cosine to the 5th power of x divided by 5 plus c, and there we go. I think I did the exact same problem with sines. Now this one has cosines. All right, no biggie, right? See how many more I've got. All right, so here, what should u be? All right, well, we've got an exponent, so I think the u should be the exponent. So u is cotangent to x. If we take the derivative cotangent to x, du dx equals, we have the derivative of the cotangent blob times the derivative of the blob. So that's going to be du equals, derivative of cotangent blob would be negative cosecant squared blob, and the derivative of the blob is times 2. So du equals negative cosecant, negative 2 cosecant 2x squared dx. We've got everything but the negative. So negative du equals 2 cosecant squared 2x dx. So all we have to do now is rewrite that. The negative's outside. And then we've just got e to the u du. Right? Everything's been rewritten, right? So this part here is the u, and all of this is the negative du. And so negative e to the u plus c is the integral, and we just can replace that. So f of x equals negative e to the cotangent 2x plus c. So e, really easy to work with. And we know that if we took the derivative, we'd have e to the blob, and the derivative of the blob is right up there. And that's it, right? This one is, yep, this is another lesson. So thanks for watching. Bye for now. Oh, by the way, in the next set of videos, we're going to look at integrating the inverse trig functions, and then we'll look at, well, how about substitution with where we've got definite integrals. So those will be the next 2 series of lessons, and that will finish off substitution. All right, bye for now.